Okay, so for the next question that we have today, it is asking us, what is the acceleration of an object sliding down a frictionless inclined plane in terms of acceleration due to gravity? Okay, so let's actually draw maybe a situation of what this looks like. So here we have like a ramp or an inclined plane with an angle of theta. We don't know what it is. We're trying to find the acceleration in terms of theta. Okay, so let's say we got a slider, or maybe let's say we have a skateboarder because we want to represent something without friction. Nice skateboarder. So we want to represent this as like a free body diagram. Okay, so let's consider what forces we have. It says frictionless, so there's no friction here, which is nothing to be, which is cool. Nothing, no friction. That's just going to be an additional step, but we're not going to need to do that. So we have our straight down gravity force, Fg, and maybe as a green force, we have our normal force, Fn. Now, if we zoom into here and maybe draw like a line like this that is perpendicular to the surface of the ramp, we can see that if we define our axes like this, maybe this is x and this is y, we're only going to have an acceleration in the x direction. We're only going to go down the slope. We're not going to be like, sinking into the slope, right? That would be like a non-zero y net force, but we have to have a 0 y net force. The only resulting force is going to be in the x direction. Okay, so what's going to happen here is we know that our gravity, we can break this down into components. Let's make the components a different color, maybe in red, like a raspberry. Here we have our FGY, and here we have our FGX. We know that FGY has to be equal to FGN. FGX is only unbalanced force. And we know that this angle here is going to be the same as the angle of the slope. So if we wanted to get the FGX component, this is just going to be equal to our mass times gravity. That's the regular Fg. And then we have to multiply by the by sine angle. Sine of the angle of the slope. Okay, so that's pretty cool, fine and dandy. And if we wanted to extract the acceleration, divide out mass for acceleration, we get A is equal to G sine theta. Okay, so the acceleration due to gravity multiplied by the sine of the angle, that will give you your acceleration down the ramp. Okay, and that is precisely what we have down here, and that is awesome. So yeah, the above solution is good. It's good. Awesome. Big high five.